All right, everyone, this is part 2 of the video helping you with the Precipitates lab. You are now at the point where you have completed the lab activity. You have written down all of the ionic compounds that you combined, and inside the table, you wrote down what the results were. And you were looking for matches, right? You were looking for 2 different combinations that gave you the same color precipitate. All right, you should find about 3 or 4 different matches, and you are going to be responsible for identifying 3 of those matches. All right, by the way, you need to make sure that you insert a picture of your results down below. Okay, you have to insert a picture of it. So take a picture on your phone or using your computer, save it to your drive, and then insert image from your Google Drive, okay? So you could also insert, you can use your camera, all right, and just take a picture directly with your laptop. A little bit messier, but that's fine. Make sure that when you take the picture, you crop it so that I'm looking expressly at your results right here, okay? Anyways, going on. So the first 3 analysis questions you need to answer on your own using the notes. These are key concepts from the chapter. Remember, this lab is being done instead of a tester quiz. All right. So now we're going to go to question number 4. Identify one pair of reactions that produced a similarly colored compound. Now, whichever one you do is entirely up to you. All right. Again, you should have 3 or 4 different matching results from your combinations. All right. I'm going to choose from my data set. And remember, this is a made up data set. All right. So yours looks nothing like this, but I'm going to choose the dark blue compound. I want to figure out what that dark blue compound is. So down here, I am going to identify the dark blue precipitate. In case you didn't read the notes from this section, a precipitate is just a solid compound that can result from combining 2 dissolved substances together. So the blue precipitate, maybe you're going to do the red or the yellow or the orange or the cloudy white. I'm going to do this make-believe blue precipitate. All right, next, type in the 2 combinations of ionic compounds that produced that color. Well, instead of typing, I am just going to go pull them directly from the chart here, okay? So this dark blue was produced from KOH, potassium hydroxide, and copper 2 nitrate. So I'm going to grab that, KOH. All right, bring that in. And what else? KOH and CuNO3 too. That was one combination that produced the dark blue precipitate. The other combination was NaOH, sodium hydroxide, and once again, copper 2 nitrate. So those are the 2 combinations that produced a dark blue precipitate. So I start by identifying the 2 combinations that produced the dark blue. All right, so there we go. I'm doing the dark blue precipitate, and these were the 2 combinations that produced the dark blue precipitate. So now the next step is I need to break these compounds down into the ions that made them up. So combination 1 of potassium hydroxide and copper 2 nitrate. The positive ions were the copper, all right, positive K with a +1 charge, and I'm going to use, sorry. All right, there we go, and the copper, Cu2+, Cu2+. All right. By the way, in case you're wondering, how do I know it's a 2+? I know it's a 2+ copper because it took 2 nitrates to cancel out the charge. So those are the 2 positive, aka cations, present. The 2 anions, negative ions present in combination 1 were the hydroxide, so OH with a 1- charge, control, period, to bring it up, and the nitrate, NO3 with a 1- charge. NO3 with a 1- charge. Control, period, control comma. Okay, so these were the positive and negative ions that were present in my first combination. Now I need to do that again for combination 2. All right, I need to break down these ions, and I will do so. Pause the video. Okay, so I've got both combinations of ions written down. So this was all of the stuff present in the first combination that gave me the dark blue. And these were all the ions present in the second combination that gave me the dark blue compound. Now, I need to figure out what that dark blue compound was. All right? The dark blue compound must be formed from ions so that you can get the same compound in both combinations. Let me tell you what I mean. You might say, oh, Mr. Gucci, I think the dark blue compound was made out of potassium and nitrate. All right, potassium nitrate. Well, guess what? You can form potassium and nitrate from the ingredients in the first combination, but you can't in the second combination. The second combination did not have potassium at all. So that dark blue compound can't have been potassium nitrate because you couldn't form it over here. It must be present in both compounds. So you might be thinking, okay, maybe it was copper nitrate. Maybe it was the copper 2 nitrate. Look, I can make that in both cases. Well, copper 2 nitrate was one of the reactants that you added. So clearly that can't be the dark blue compound because it wasn't dark blue when you added it. So you need to make something new, all right? As well, it must be made of a positive and negative ion. So maybe you're thinking, oh, okay, I bet it's made of the OH and the NO3. I bet that dark blue stuff that I made was made of OH 1 minus and NO3 1 minus. Look, it's present in both combinations. But you can't do that because an ionic compound must be made of a positive ion and a negative ion. So by the time you're done looking through all of these, it turns out there's only one combination that is present in both, all right? And that is the combination of copper 2 ions and hydroxide. Look, I could make copper 2 hydroxide in the first combination, and I can also make it in the second combination as well. So both of these compounds, both these combinations that made a dark blue compound were also able to produce copper 2 hydroxide. So that dark blue stuff, therefore, is copper 2 hydroxide. And so that's what you got to put down here, all right? Copper 2 hydroxide. You need the name and the formula, all right? Now, just in case you're having some trouble with it, all right, copper 2, Cu 2 plus, all right? All right, and then you have hydroxide, OH, a polyatomic ion with a 1 minus charge. Now, make that look nicer. All right, these charges don't cancel. That's 2 plus, that's 1 minus. The charges aren't going to cancel. All right, but if we had another hydroxide here, now the charges do cancel. The 2 plus from the copper ion will be canceled out by both of these 1 minuses. So the formula is Cu, let's see here, I'm going to get this, move this down out of the way a bit. All right, so the formula must be then Cu, 1 copper, OH, 2 hydroxide, copper 2 hydroxide. Okay, so I'm going to go type that in. All right, copper 2 hydroxide, CuOH2. All right, so there we go. That's what I made, and that's the answer. So you need to do this for the 3 different pairs of ionic compounds that produced similar looking results in your experiment. Now listen, Mr. Gucci is a bit of a jerk. All right, I will freely admit it. I do it because life is hard, and I want to prepare you for the fact that sometimes in life there's no easy answers. And so for the 4 matching combinations that your testing produced, one of them does not have a compound in common. One of them, the two compounds merely look similar, but they are in fact not made of the same stuff. And this happens in chemistry. All right, think about salt and sugar. They are both white translucent crystals, but they are very, very different things. So maybe the two red substances you produced were both red, but were different things. The two yellow substances, maybe they were both yellow, but they were actually different things. So of the four different combinations, if you pick the three that have a matching compound, then good. But if you pick the fourth one that does not have a matching compound, you have to say no common compound form. Only one of the four does not form a matching compound. And there you go. Good luck